Okay, we are back for the last section of chapter 2, which is going to be graphing absolute value um, equations and inequalities in two variables. Okay, so what we're going to do here is almost like a little task for us to work on so that we can see all the different types of things that can happen to the graph of the absolute value. Especially when we have like different things going on. Like as we can see here, we have y is equal to the absolute value of x. This is the absolute value of x and then minus 6. And then this one's the absolute value of x minus 5 inside the absolute value, and then multiplying by a number outside of that. And we're going to see what that happened, or what happens basically every single time that any of these occur, because there's pretty distinct patterns. So hopefully we'll figure this out. Okay, so what I want you to do is I'm going to kind of demonstrate the very first thing, and then what I want you to do is pause the video and do the other two, or the other three. Okay, so I'm going to do this first one here, which I will just go ahead and do in my black pen here. So I'll just go ahead and do this. And so basically what we're going to do is we're going to introduce this idea of the parent function. Okay, and what this means is that when I'm talking about absolute value equations or inequalities, specifically the graphs of it, the most simple form, like the most basic generic, like the least amount of extra stuff going on, is going to be the parent function. So for us, that's going to be y is equal to the absolute value of x. There's no addition, subtraction, multiplication really of any kind, and we are going to see how all those other things impact the general parent function. So what I'm going to do is I'm going to get another sheet of paper here, and we're just going to use this to show a little bit of work. Okay, so for this first, I want to figure out what the y value is when the x value is -2. So to start, my x value is -2. So that means I want y is equal to the absolute value of -2. Okay, and so what is the absolute value of -2? Well, that is 2. Okay, and so then we have this ordered pair, -2, 2. Okay, let's go ahead and do the next one. So when x is -1, y is equal to the absolute value of -1, and the absolute value of -1 is 1. So we have this ordered pair, -1, 1. Okay, so this is 1. Okay, so what about when x is 0? We have y is equal to the absolute value of 0, meaning what is the distance 0 is from 0? Well, that is 0. So we have this ordered pair 0, 0. All right. And then we have x is equal to 1. So y is equal to the absolute value of 1. And that means y is equal to 1 because 1 is 1 unit away from 0. So it's 1, 1. And then lastly, we're going to do when x is 2 here. Absolute value of 2. Meaning y is equal to 2. So we have this ordered pair 2, 2. Okay, so then what I would like you to do is, okay, so hopefully you've just followed along with what I was doing here. This is just to show your work to help you get this. Some of this you might be able to do in your head, which is totally fine. But let's go ahead and graph all of these ordered pairs here for the parent function. And I'm going to do this in black. Okay, so if you look at your work or your sheet above, our very first ordered pair is -2, 2, so -2, 2. Okay, and then we have -1, 1, 0, 0, 1, 1, 2, 2. Okay, and so what this does is it kind of creates a perfect little V. Okay, it's a V going from 0, 0, kind of all the way out, out here, creating a V. Okay, and so then this is y is equal to the absolute value of x. Okay, and so this is what the parent function is. So what I want you to do is I want you to, preferably in a different color, go ahead and do the same thing for each one of these tables and then graph. And then off to the side, I want you to tell me, like, what does this -5 do? What does this -6 do? And what does this -3 do? So go ahead and pause the video and go ahead and try that on your own. Okay, so I'm assuming that you all have already kind of filled out the tables and done the graph and already tried to figure out what each of these do on your own. So now I'm going to go through this, okay? I didn't want to go through how we get every single order pair from each of these because I'm really more concerned about the graph. So here are your results that you should have gotten on the graph. Okay, so let's go ahead and graph this red one here I have up in the upper right hand corner. Okay, and so this is going to be -2, -4. So -2, -4. 1, 2, 3, 4. Okay, -1, -5. 0, -6, 1, -5. Okay, so what are some things that we're seeing as a result from the red to the black line? Okay, because that's what I'm most interested in. From black to red, what's going on? So this is y is equal to the absolute value of x minus 6. Okay, what's happening here? Well, hopefully you notice that, they're both facing up. They're both still a v. So what is this -6 doing to the graph? Well, hopefully you've kind of figured out eventually they're all 1, 2, 3, 4, 5, 6. All these points are just 6 units lower. 1, 2, 3, 4, 5, 6. Okay, so they're all just 6 units lower, okay? So what does that mean, okay? That means that this value here is going to move it up or down. But we need to know when up and when down. Okay, well, this moved it down and it was negative, so it's pretty reasonable to assume that when it's negative, it's down, and when it's positive, it's up. Okay, so this one here we're going to do next is blue. So blue is when that subtraction is on the inside of the absolute value symbol here. Okay, so let's go ahead and see what that looks like. That will be 3 positive 2. So 1, 2, 3, positive 1, 2. Next one is 4, 1, 5, 0, 6, 1, and then 7, 2. Okay, just plotting my ordered pairs. I'm going to connect them all best I can. Okay. And then this is the line y is equal to the absolute value of x minus 5, all inside of that absolute value. Okay, so let's just look again what happened. Okay, it looks as though it might have been mirrored almost along this line, but if we look closely enough, specifically we look, it goes 1, 2, 3, 4, 5. Well, here 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. So what happened to all of these points? The whole thing has just been shifted off to the right. So when you have problems in here, it is going to shift it to the right or the left. Okay, so addition and subtraction on the inside of the absolute value is going to shift it to the right. Now, this is going to be a little bit backwards from what you see, but we'll elaborate upon it. Whenever it says x minus a number, that's actually going to shift it off to the right, x minus a number. And when it's x plus a number, okay, it's going to actually move it to the left. And this is opposite of what you would probably intuitively think it would be. But again, we will talk about exactly why that's the case here in a moment when we kind of formalize this here. Okay, but the big thing we need to know is addition or subtraction outside of the absolute value will take your parent function. It will move it up or down. This one here will move it left and right. Okay, lastly, what about if I'm multiplying on the outside of this? Okay, if I have multiplication on the outside of the absolute value, Okay, so we're going to get negative 2, negative 1, 2, 3, 4, 5, 6. Okay. All right. And then here and here. Okay. Alrighty, get a little closer here. Okay, and I'm actually going to highlight this one here because then we don't have two black lines. We have a highlighted line, and then we have a black line as well because I don't have a third color. All right, so this is going to be y is equal to the y is equal to negative 3 times the absolute value of x. Okay, so what's happening in this one? Well, they both have this like same pivotal point here. But the biggest difference is like it's become narrower. Okay, so really what this is going to do is it's going to be narrower. What's the other big thing is it opens up or down. Okay, so this value up front is going to open it up or down. Okay, when do you think it's going to open down? Well, this one opened down and this number was negative, so it's reasonable to assume it's going to open down when that number's negative. Okay, when is it going to open up? When it's positive. Okay, so if this was a 3x, it would open up 3. Okay, the other thing is it's going to do is it makes it narrower and or wider. Okay, so this one is quite a bit narrower, but it can also make it wider. Right, this highlighted line is much narrower than the original black line or really any of the lines. Okay, why? Okay, so because we're multiplying by a value every time. So whenever the absolute value of, I'm going to call it a, whenever this value here is greater than 1, it is going to be narrower. Where when that value, again, I'm going to call it a, and you'll see why in a little bit. When it's less than 1, it's going to be wider. Okay, it's going to be more gradual. Okay, so hopefully these are some observations that you came to. Like maybe you didn't understand when is it up and down and when is it right or left, but you understood that like, hey, this is going to make it move up and down, this is going to make it move right or left, and this is going to open up, open down, and the narrowing part. Okay, so let's go ahead and formalize this. Try to keep this close because we're going to use this, which is going to bring up our general form of a absolute value equation, and we're going to call this vertex form. Okay. All right, and so the a, it's going to be y is equal to a times the absolute value of x minus h, and then plus k. And a, h, and k all do different things. So a was if we look on our front page, that was like my highlighted line. K was my red, and H was my blue. Okay, and they all did different things, so let's go ahead and formalize exactly. So A, let's go ahead and find the one that's in the A port here. That was when we had negative 3, right? It opened up and down, okay? So it is going to open up. So I can know a lot about the graph just by looking at the equation, and really I could almost sketch the graph pretty accurately just by knowing what these different values do. Okay, so specifically I know that the graph is going to open up this way as opposed to opening down this way. So open up, open down. It's going to open up specifically when A is greater than 0, which means it's positive. Okay, when A is greater than 0, it's going to open up because the A value is positive. Okay, it is also going to open down when A is less than 0, meaning that the A value is negative. Okay, it does do other things, right? It also made it narrower and wider, and we actually completely said exactly how and why. Okay, when the A value, it's going to be narrower when the absolute value of A is greater than 1, excuse me. And it's wider when the absolute value of a is less than 1. Okay, so there's a few different things that the a value does, but it gives you a really good idea of what's happening. Okay, so let's move on to h. H is the value that's going to be inside of the absolute value symbol. Okay, we know that this is going to move it right and left. Okay, it's going to move it right when a is greater than 0, meaning it's positive. Okay, this is kind of what you would think it would be, but you got to be very, very careful about this. And in fact, I'm telling you right now, it is very easy and understandable mistake to kind of screw up the h value because it says x minus h. So when I plug a positive value in there, it's going to say x, like if I plug in positive 6 in for h, it's going to say x minus 6. And one is going to easily think that, well, it's negative, it's going to move to the left. But the basic form calls for subtraction. So when I plug a positive value in there, it's going to show up as subtraction, even though the a value is positive. It can be a kind of a little confusing, so I also like to write this. It's going to show up as like x minus a number. Okay, so for a lot of people, I know that they have found this helpful. When it says x minus a number, it's going to be moving to the right. It seems backwards, but really, if you kind of sit and think about the general form, it does make some sense. Okay, and then lastly, it will move to the left when the a value is less than 0, meaning it's negative. And again, this is just equally backwards because it will also show up in the general form as x plus a number. Why? Because if I replace h with a negative 5, I would have x minus negative 5. Well, what is minusing a negative? Well, it's addition. So you might look at this and say, hey, my h value is a positive value. And it looks like it is, but it is not because it's actually negative, even though we have a plus sign, because the general form has subtraction in it. Okay? I think it's even like worth mentioning that this is like this is the one that can be pretty tricky. So like you really want to focus a lot of your attention maybe on this one, more so than the others, because this is the one that is most likely to screw you up. Okay, but that's all it does do is it moves it left, it moves it right. Okay, and then lastly, we want to talk about k. K was our red one. So when I looked at this, we said it moves it up and down. When this was minus 6, it shifted our whole graph down 6 units. Okay, so this one is very, very straightforward. Okay, it is going to move it up when my k value is greater than 0, meaning that it's positive. And then it's going to move it down when my k value is less than 0, meaning it's negative. And this one works exactly the way that you would want it to work. Okay, and then I did just realize a mistake here. This should not be a. These should be h's because that's the value we're talking about. Okay, so I apologize for that. Hopefully you all were catching that as you went on, but luckily I caught it before I published the video. Okay, so this should be h's. H's is less than 0 and h is greater than 0. Okay, so what is super important about this is this graph normally starts at 0, 0. Right? The parent function typically, not typically, always does, starts at 0, 0. But like as I looked at this, I know that my vertex, that's why it's called vertex form, is going to shift based on how it is. So this one here, I can look at this right off the bat and I already know, well, my vertex is going to be shifted from 0, 0, right 5. Just by looking at this. And then that gives me a starting point, and then I don't really have to guess and check quite as much. Okay? Same here. There's no number out here, so it's not up or down. There's no number in here. It's not left or right. I know it's going to start at 0, 0. Here, I know it's not moved to left or right, but I do know it's shifted down 6, so I know my graph is going to start at -6, or 0, -6. It's just going to move down 6. So this is very helpful to us, and we're going to see that here in a minute. Okay, so let's actually go ahead and do one in A. And what I want you to do is go ahead and use this table, but eventually at some point I think you'll have it just figured out where you won't need the table, is describe the transformations, okay? Describe how how this graph would compare to y equals the absolute value of x. In other words, just saying describe the transformation. Okay, so let's just go ahead and figure out where the vertex is moved, okay? So it is translated. Okay, let's talk about left and right. Okay, x plus 1. X plus 1. How is that moving that middle vertex point? Okay, that vertex being the peak of the v. So where is that moved if it's plus 1? So let's go up here and look. Okay, it's inside the absolute value symbol, so I know I'm looking at my h value. And again, this is tricky, right? It appears as though this is positive, but really the basic one calls for subtraction. So maybe it might help like x plus a number. That's what I'm seeing. I'm seeing x plus a number. That means it's going to move it left. Okay, so this is translated left, but I want a number as well, left, and then 1 unit here. Okay, what about this minus 6? What is that going to do? It's going to translate it. Okay, so it's going to be translated, well, minus 6. Let's go ahead and look. Okay, that's kind of on the outside here. So outside here, I'm looking for k. Okay, well, if it's positive, it's going to move up. And if it's negative, it's going to move down. Well, this is negative, so this is going to be down. Down how many units? 6. Okay, then I got to look at the a value. The a value here. Okay, there's 2 things that you're going to get from the a value. Open up, open down, narrower, wider. Okay, so let's go ahead and look at this. Negative 2. So is that going to open it up or down? Okay, we know when it's positive, it's going to open up. And when it's negative, it's going to open down. Mine is negative, so it's going to open down. And then lastly, wider or narrower. When the absolute value of a is greater than 1, it's going to be narrower. And when the absolute value of a is less than 1, it's going to be wider. What is the absolute value of negative 2? Well, it's 2, meaning that this is going to be a narrower graph. Okay, and that's all I'm looking at. But that's very powerful if you think about it. Like, there's not really a whole lot of like number crunching and plotting points going, and I already kind of know a lot about what this graph is. I know that it's moved to the left 1 and down 6, and that it opens down and it's narrower than the normal one. That's pretty powerful, because that's going to get you a long way through some of these problems without having to do a whole lot of work. Okay, I think it's best for you to pause the video and try letter A on your own, and when you're done, check it with me. And I'm assuming that you've already done that, so let's go ahead and try this. Okay, so minus 4. Okay, minus 4 on the inside here is the one that I have to be careful for. It's tricky. Minus 4 in here really means that my h value is positive, because it says x minus a number. Okay, and so that means it's going to translate it to the right. Okay, so this is going to be moved to the right. 4. Okay, what about the plus 3? Plus 3 is my k value. My k value is right here, so that's either going to move it up or down. Okay, and so k is positive, so it will move it up. So this one's going to be moved up 3. Okay, this 1/2 here. Is that going to open it up or open it down? Okay, so you want to look at your a value here. Okay, it's going to open up because it's positive. Okay, positive a values are going to have it open up. And then lastly, wider or narrower. Okay, this specific one, what's the absolute value of a 1/2? Well, it's a 1/2, and is that greater than or less than 1? That is less than 1, meaning that it is going to be a little bit wider than the parent function. Okay. So that is it for describing the transformations. That being said, these transformations, knowing what the a value, the h value, and the k value are very important, because they make graphing so simple if you know what they do. But if you don't, then you're going to have to do a lot of plugging in x's, getting out y values, plotting the point back and forth, back and forth. And that can be quite difficult, where if you understand what these transformations do, it helps you quite a bit. So let's go ahead and see how they're going to help you. Okay, so let's just look at number 2. I want to graph y is equal to that negative 1/2. So right off the bat, I already know it's wider, and it's going to open down, times the absolute value of x plus 7, and then minus 4. So right here, this is kind of telling me my vertex normally is at 0, 0, but it's being shifted to the left 7 and down 4 for the same reason that we discussed above. So I can just start at 0, 0, and go left 7, 1, 2, 3, 4, 5, 6, 7, and then down 4. 1, 2, 3, 4. Okay, so there's my vertex. It's the absolute highest or lowest point. Okay, and I like to draw a little axis of symmetry through it because this whole thing is symmetrical. Right, all right. Okay, so there is my lowest or highest point. So let's think about whether this is going to be a highest or lowest point. If we know it opens down because this is negative, this a value is negative, that means that this is going to be a highest point. So what you can really do is only moving off to the right, you can treat this as the slope. So what would a slope of negative 1/2 be? Well, it would tell me down 1, right 2. Well, then I can just take my point and I can start here at my vertex and go down 1, right 2. Down 1, right 2. Down 1, right 2. Now, it's not slope, but it very much acts like it. And the reason why it's not slope is because slope is really a concept only applied to like straight lines. Well, it is a straight line off to this. But I did say that this thing is symmetrical. So this becomes very handy when we're talking about the other side, because I have one side, I just need to do the other. Well, if it is symmetrical on this side, that means it can just be mirrored across. So if you recall back from geometry, if I want to reflect this point across this red line, I just have to say, well, it's 2 units to the line, meaning it'll be 2 units away from the line as well. Okay, and then here it would be 1, 2, 3, 4, 1, 2, 3, and at 4 would be off the graph, so this is about all I need. Okay, so again, this off to the right side is going to act like the slope, and in fact, I would encourage you to treat it as such, but it's not going to act like the slope off to the other side. You're going to need to mirror your points across because the fact that it's symmetrical is going to be helpful to you. Okay. We are going to get more practice with this, but I think now is a good time for you to at least try yourself a little bit on letter B. Pause the video, try it, and then check your work with me. Okay, so as I'm looking at this one here, I know that my vertex has been moved to the right 3 and then up 4. So I can start at 0, 0 because that's where it normally starts, and move to the right 3, 1, 2, 3, and then up 4. 1, 2, 3, 4. Okay, and so that's where my whole graph is going to start. So then it's also important to think about whether my graph is going to be moving or opening up or down from this point. So is this point going to be a minimum or a maximum? Is it going to be a lowest point, minimum, or highest point, maximum? Like, for example, this was a maximum because it's at the absolute highest point relative to all of its other ones. Well, this one's going to open up because this is positive, meaning that this is going to be my lowest point, meaning it's a minimum. Okay, so this acts on the right side only as if it's slope, meaning I can go up 2 and right 1. Up 2, right 1. Okay, and I can just continue that forever. And then I can mirror these points across. So if it takes me 1 unit to get to the line, it's going to take me 1 unit to get away from the line. 2 units to get to the line, 2 units to get away from the line. 3 units to the line, 3 units away from the line. And then I can just connect my dots in a V shape. Alrighty, and that's it. Okay, just a few more examples, and then we are done with this chapter. What about if we have absolute or inequalities? Okay, so the kind of concepts that I've taught you about inequalities are going to hold true with this, which is great. For example, when do we have bold lines and dashed lines? Think about that to yourself. Well, it's going to be a bold line when it's like greater than or less than or equal to. Whenever you have or equal to, it's going to be a bold line. So right off the bat, I know that this boundary is going to have a not going to have a bold line. It's going to have a dashed line. Where this one will have a bold line because it's greater than or equal to. And then also where we shade. Where we shade can be use the same concept where you can just test an ordered pair. And it can be any ordered pair you want. Often you're going to see 0, 0. So all those concepts are the exact same. So really these problems really aren't that big of a stretch extra, although they do require a little bit more work. Okay, so what I want to do here is go ahead and graph this here. I know that my vertex is normally at 0, 0, but it's been moved to the left 2 and down 4. Left 2, 1, 2, and then down 4. 1, 2, 3, 4. Okay, and then I need to have a slope. Okay, so there's no number out here, so that means it's the same width as the parent function. And so it would just be a slope of 1, right? There's no value there, so that means there is an implied 1. A sneaky one, some might say. Okay, so I'm going to draw my axis of symmetry here. Okay. And then what I'm going to do is I'm just going to go ahead and move up 1 over 1 here on my graph. Because as I move off to the right, that is what my graph is going to look like. Okay, now I can reflect these points, but I do also have noticed a pattern that if my slope is 1 here, that means it's going to be the opposite of that on the other side. So that would be up 1, left 1 here. Just symmetrically creating a V. Okay, and then I can go ahead and connect my dots in a dashed pattern because it is just greater than, it is not greater than or equal to. And let's think about what that means as far as solutions go. What does that mean as far as solutions go? It means that if you're on that line, you're on that boundary line, that means it is not part of this solution set. If you're in the other part, though, it may or may not be a solution. So again, just the same as half planes, our solutions are going to be all in this area or all in this area. Okay, one or the other, and we don't know. So what we can do is the same idea that we did before and test 0, 0. Okay, so that means that I can say 0 is greater than the absolute value of 0 plus 2 minus 4. So this is 0 is greater than the absolute value of 2 minus 4, which means 0 is greater than 2 minus 4 because the absolute value of 2 is 2, meaning that 0 is greater than negative 2. Okay, is this true or false? This is true. 0 is greater than negative 2. So what does that mean? That means the side with 0, 0 is 0, 0 is a solution. And all my solutions, again, are either all on this point, or all on this side, or all on this side. It can't be mixed and matched on both sides of our boundary line. So they're all in here, meaning it's all kind of inside of the V. So I can go ahead and get my highlighter out. And then I can go ahead and highlight this inside part. Okay. And if it was false, we would shade on the opposite side because we would have tested 0, 0, found out that it's not a solution, meaning that there's no solutions on that side at all. Because either one point is a solution on that side, or if one point's a solution on that side, then all of them are. Okay, let's go ahead and just go over what is and is not a solution. Is this ordered pair right here a solution? Hopefully you're saying no, not in the shaded region. Okay, what about here? This one would be. It's inside my shaded region, meaning it's a solution. What about this point right there on the line? In this situation, it would be no, because it's strictly greater than, not greater than or equal to. This line, this boundary line, is when it's equal to. Okay, this is when it's greater than. This is when it's less than. But it's not equal to. It's strictly greater than. So a point on the line is not a solution for this one. Okay, let's do one more for 4. Then I'll let you do C and D, and then you can check your work with me here in a minute. Okay, letter D is basically the exact same thing. The only difference is we have less than. Okay, so let's go ahead and test it out. Okay, I know that the vertex is normally at 0, 0, but it's being moved to the right 3 and up 1. So let's go ahead and do that. 1, 2, 3, and up 1. Okay, so then I can go ahead and make my axis of symmetry. Alrighty, that looks good to me. Okay, axis of symmetry. All my points are going to be symmetrical about this red line. Okay, and then I have off to the right of that axis of symmetry, I kind of have a slope of -2, meaning down to right 1, down to right 1, down to right 1, down to right 1. Okay, and then I can reflect all of these points across, or just kind of go in the opposite direction. Okay, now with this one, would I connect these dots in a bold line, or would I have a dashed line like the one above? Well, this particular one, we would have a bold line because it's less than or equal to. That or equal to part indicates to me that I need to have a bold line. Alrighty. Okay. And then lastly, I need to figure out where to shade. Okay, so I'm going to test 0, 0. Okay. And then that means that 0 is going to be less than or equal to -2 times the absolute value of the 0 minus 3 plus 1. Okay, so 0 is less than or equal to -2 times the absolute value of -3 plus 1. Okay, so order of operations, this is one that we may not have talked about, but you would do like grouping symbols first, which is why I do the absolute value symbol together. That is a grouping symbol, though you can't distribute. We want to we want to do the absolute value first. So what is the absolute value of -3? It is +3. So I have -2 times +3 plus 1. -2 times 3 is -6. And then 0 is less than or equal to -5. Okay, 0 is less than or equal to -5. Is this true or is this false? Okay, this is false. 0 is greater than -5, meaning that, again, all of my solutions are either outside of this V or inside of this V. Okay, we tested 0, 0 and found out that this point outside of the V is not a solution, meaning that all of my solutions have to lie on the like the opposite side. They're either all on this side or all on this side. We found out this is not, so that means they're all in here. Okay, so this here is going to be my my solution set. Okay, so lastly, let's go ahead and identify some solutions. Would this point right here be a solution? Yes, it would. It's inside my shaded region. This is the area where my y values are less than all of this. Okay, what about here? This would be no, it's outside of my area. This is the area where it's greater than. Okay, what about this point here? Well, this circumstance is different than the previous one above because this is less than or equal to, meaning that if it is equal, it is part of the solution set. So anything on the line here, on my boundary line, would be part of the solution. Okay, so what I want you to do is just go ahead and do C and D on your own, check it with my work, and then you can move on to the homework for this section. Okay, and so I'm assuming that you've already paused the video and done that, and so now you're just trying to see what your work is going to look like here. So here I know it's right 3 up 5, right 3, 1, 2, 3 up 5, 1, 2, 3, 4, 5, and then kind of a slope of -1 here. Okay, and I think I'm done making points there. This is going to be a bold line because it's greater than or equal to. So bold line here, and a bold line here. Okay. I probably should put my axis of symmetry there just to be consistent, though it's actually not super required of all of you, but it's quite helpful. And just kind of understanding this axis of symmetry is helpful. Okay, and then I just have to test 0, 0. Okay, so 0 is going to be greater than or equal to the opposite of the absolute value of 0 minus 3 plus 5. So 0 is greater than or equal to the opposite of the absolute value of negative 3 plus 5. Well, that again, we have to do this first. So the absolute value of negative 3 is 3. So here we have 0 is the opposite of 3 plus 5. So 0 is greater than or equal to 2, which is false. Okay, so we found out that it's not 0, 0, meaning my shaded region is outside of this. Anything in the shaded region is going to be a solution. Okay, anything on the line is also part of the solution set as well. Okay, because it's greater than or equal to. It's that equal to part that makes it a solution. Okay. All right, so that's what number or letter C is going to look like. Okay, let's go ahead and move on to letter D, and then we'll be done. So this one here is moved to the left 1 and up 6. So left 1, up 6. 1, 2, 3, 4, 5, 6. That's right here. So let's draw my axis of symmetry. Okay, and then it's gonna like open downward, down 2, right, and then right 1. So down 2, right 1, and let's keep this pattern going. And then kind of the opposite of that here. On the opposite side here, because it is symmetrical. Okay, this one here is also going to be a bold line because it's less than or equal to, meaning that points on the line are part of the solution set. Okay, so here's that, and then here's this one here. Okay, so there's my boundary, and then now I just have to figure out where to shade. And we can go ahead and test 0, 0. Okay, now the only time you wouldn't test 0, 0 is if 0, 0 was part of the graph. And in that circumstance, you would not test 0, 0. You just pick any other point you want. It doesn't matter, but that could be helpful to know in case it pops up. So 0, and it's less than or equal to negative 2 times the absolute value of 0 plus 1. And then plus 6. Okay, so 0 is less than or equal to the negative 2 times the absolute value of 1 plus 6. Well, the absolute value of 1 is 1, so we have 0 is less than or equal to negative 2 times 1 plus 6. Negative 2 times 1 is negative 2 plus 6. Negative 2 plus 6 is 4. So 0 is less than or equal to 4. That is true. Okay, and so this one here we get to shade inside of the V because we tested 0, 0 and found out to be a solution, so that means the side with 0, 0 has all of the solutions. All right. And again, anything in my highlighted shaded region is a solution. Anything on the line is a solution for this one because it's a bold line. All right. Otherwise, that is the end of this lesson. Go ahead and move on to the homework, and I guess I'll see you next time for the beginning of Chapter 3.